I used to be an engineer, a job that involves a lot of tough math problems, especially when you're dealing with graphics. Nowadays I teach math. The toughest part of that job is keeping the students engaged. The students, of course, have their own agenda. I was inspired by a talk I heard last year by Dr. James Paul G., who asks, why can't school be more like a video game? This is my attempt to answer his question. This is the campus prototype. I built it using some video game technology, so it looks quite a bit like a video game. The campus itself is divided into several small buildings. Each small building contains a specific lesson. The building we're going to be looking at has a lesson on the Pythagorean theorem. Let's take a closer look at our avatar. This represents our student, and by piloting this avatar around, it gives the student a sense of self and place.
This is a century-old method of figuring out.
That's old.
So, the idea of the Pythagorean theorem is to figure out how long one side of a triangle is.
Okay.
So, the Pythagorean theorem is a squared.
Good teachers know that students often learn best from their peers and that good learning is social learning. As we step into the classroom, the first thing we notice is that there are other avatars here. Now, these aren't game artifacts. These are actually being operated by other students, and we can carry on a conversation with them using a headset with a mic.
You know, I knew the formula. It was just that I said a squared plus c squared equals b squared. I meant to say a squared minus c squared equals b squared. And then we square root it, and that's what b is.
This results in a social, cooperative style of learning that engages us emotionally, unlike traditional educational software that can produce a feeling of isolation. It's also a great approach for auditory learners.
So the hypotenuse, which is right here, is also c. And what would that equal?
This style of interaction seems foreign to a lot of adults, but it comes naturally to kids who've grown up with modern video games.
Game. Obviously, these guys aren't as coordinated as we are, so they get overwhelmed in the beginning.
Okay, Control Guy, you stay there and watch this hallway over here. Dad, you watch, you watch over here.
Alright.
Go down.
Theorem tells us.
Now let's take a look at our lesson, which starts off with some direct instruction. This environment allows us to bring resources in from the World Wide Web. So in this case, we've borrowed a lecture recorded by Sal Khan at the Khan Academy. He's got over 1,000 of these. It's really amazing, and they're quite good.
Is going to be 30. Let's do another one of these. Maybe I want to keep this Pythagorean theorem right there, just so we always remember what we're referring to. So let's say I have a triangle that looks like this. Let's say it looks like that. It looks like that, and this is the right angle.
Here we have the ability to pause the
angle.
recording, talk it over, discuss, ask each other questions, rewind the video if necessary, so it becomes part of a real social experience.
The right triangle. This side over here has length 9. This side over here.
So C is the bigger number, and then A is the smaller number. So if you subtract them, you're probably going to get B squared. So B squared would be 25 minus 9. So that equals 16.
Another great way to engage students is to give them a hands-on experience with manipulatives. Most teachers would love to use them more, but the logistics of using them just eats up too much instructional time. Here the computer handles the logistics for us. These are really great for visual learners. Here I'm experimenting with integrating the geometric with the symbolic. There's an amazing amount of good stuff available out on the web that we can pull in for students that want to go into more depth. Here are just a few examples. Again, the idea here is to engage the student as much as possible and to put them in control of the process as much as we can. Regardless of the resources available, some people will need a little extra help. I wanted the student to still feel like they're in control of the process here, so what I've done is I've tried to provide them with a set of tools that they can use to get themselves unstuck. Of course, the first step would be to try to discuss the issue with the other students in the room, but if they're not able to answer the question, the student's going to need some additional help. Each student would be assigned to a study group. Now, the members of their study group wouldn't necessarily be in the same classroom at the same time because they're all working independently at their own pace. But we want to provide the student with the ability to send an instant message out to the entire study group and see if someone from that group is able to answer their question. As an alternative, they might have a special friend out there or a peer mentor who they really trust to answer their question, and they'd be able to initiate a voice call with that particular person. Of course, every once in a while we're going to have a student who's exhausted all these resources and is still stuck. She's going to need some additional help, so at this point she would make use of this gong. We've allowed the student to have as much control as possible and we've automated everything we can, but at this point we really need a credentialed teacher. So by clicking on the gong, we would summon one in the form of an avatar from a pool of teachers that are standing by.
So a squared plus 21 squared is equal to 35.
I mean, for this triangle, if c is 5, what's c squared? This looks
25.
good, by the way. Yeah. So if we know that c squared is 25, and what's a squared?
A squared is 9.
Okay, so if we know what c squared is and we know what a squared is, how can we figure out what how can we figure out what b squared is?
Subtract 25, or 9 from 25?
Yes. Excellent. Since most of the process is automated, the teachers can focus on teaching, which should make them much more productive. How does the student know when they're ready to move on? Our lesson needs an integrated assessment. Once again, the team at Khan Academy has led the way. Students can move through the levels at their own pace. Some will go as fast as possible, others might hang back a bit to help a friend, which is a good way to consolidate what they've learned. If we're not satisfied with their progress, they'd be visited by the tutor. The computer can manage a variety of motivational tools for us. Here we have a collection of rewards that could be carried, worn, or ridden by an avatar. Rewards can be awarded based on individual success, team effort, or competition. Although this is still a prototype, the technology needed to build it is available today. Please contact me with any questions or suggestions. Thanks for watching.